All right, so good morning. This question is also about the angular momentum, but now the angular momentum is in terms of moment of inertia and the orientation of angular velocity. Okay, read the question very carefully. We have to concentrate on the direction of angular momentum and magnitude of angular momentum in this scenario. What is a scenario? You have a rod which is given to you. This is your rod. This is your horizontal axis about the edge of the rod. The rod is kept like this. Okay, it is kept like this. It comes like this. Okay? My hand will not come straight. Okay, the rod comes vertically downwards about this axis from A to B. If you notice, the rod's A position reaches the point B, and so we have to decide what happens to the angular momentum direction and the magnitude. Okay. Now, so far, what we have been doing, I hope you've read the question. We will decide the angular momentum direction and the uh, magnitude. Okay. So let's see what happens. I hope you've read the question. I will reduce the size of the question and let's see what happens. And we will discuss. Okay. Let's see what happens. Now, if you notice this situation, we have been using angular momentum definition as MRV, right, or R cross V. If you see my previous questions, which I've been doing off late for last 2 days, I've been using this concept, right, MR cross V. Now, in this case, you don't have a point mass. Okay, so if you don't have a point mass and a rigid body like a rod, okay, a rod going like this, right? This is my axis, and I'm going like this. Now, when the rod goes down, we have to decide the angular momentum. Angular momentum of a rigid body is given like L is equal to I omega, where L and omega are in the same direction, or omega decides the direction of L. Okay, let me give you an example to make you understand this, right? So if you have a circular motion in horizontal plane, right? So you have a circular motion in a horizontal plane. The body is going in this direction, which means it is going in anti-clockwise direction in the horizontal plane, right? On the horizontal plane, anti-clockwise direction. So this is your anti-clockwise direction. The angular momentum, right? So wrap your hands around the angular velocity, right? So angular velocity, I'm wrapping it here because this is my anti-clockwise direction. My thumb points upward. So my thumb L is pointing upwards. This represents the direction of angular velocity. So when we do questions on angular momentum, and it's a case of a rigid body, not a point mass, right? You have one angular momentum, which is this, and a second angular momentum for a rigid body motion, which is this. Obviously, we can use this formula when we do the sigma of this formula for a rigid body. We can get that expression, right? Where I is mr squared. R is the radius of gyration. But we let's keep it separate for a while, right? Don't forget to watch my video on radius of gyration. Important numerical, important topic, lot of questions expected. Okay, so we will not use this formula. We will use this formula. We now understand how to decide the direction of angular momentum, right? Because we know if we know the direction of the angular velocity, we can and we use right hand thumb rule. We wrap the right hand along the direction of the angular velocity. If the angular velocity is reversed, the thumb goes down, the thumb represents L. Now let's think through what's happening in this case. The rod actually is falling like this. So I'll just bring the camera near to this camera. So the rod is falling like this, right? So the rod is going down like this. Okay. If you see from the view we're seeing like from here, what is happening, right? And angular motion, right? And omega is getting generated, right? So you do have, I'm fixing this vertically. This is my horizontal axis and I'm bringing it down, right? So what's happening? omega exists, right? Sorry about that. So my omega exists, but since the omega, if you read the question says whether or not omega is constant, right? Which means whether this omega is constant. If omega is constant, the L will be constant, right? Obviously, the magnitude, right? But if you're going under the influence of gravity, right? The gravity is applying a torque on you. The rotational force is coming on you. So your omega keeps on increasing. You don't fall with the same omega. You fall with faster omega, right? And by the time you reach down, you're at the highest omega, right? Because you have been accelerated through a substantial angle, right? So we can apply the concepts of rotational kinematics, which is, like v square minus u square is equal to 2as. We can apply omega final square minus omega initial square is equal to 2 alpha theta equivalent, right? So we have angular acceleration here being provided by gravity. So this is a qualitative question. We're not supposed to worry about the algebraic part of it. Let's only concentrate on. So first of all, it is very clear. This body, which is falling under the influence of gravity and rotating like this, will not be able to maintain a constant omega. The omega will increase. So the magnitude of angular momentum will not be constant. Angular momentum, omega is increasing, the angular momentum will increase. First question solved. Second, direction. This is not a numerical question, more of a conceptual understanding question. Second part of the question says, what happens to the direction of motion of the angular motion of the rod? If I bring you back your attention to this, if the body is moving in a particular direction, which is clockwise or anti-clockwise, how much is the angular velocity does not matter. If it is clockwise, it is clockwise. If it is faster angular velocity, the direction is still upwards. If it is a slower angular velocity, the direction is still upwards. So the angular velocity, so far it remains in the same direction. Although the magnitude of angular momentum is impacted, the direction is not impacted, right? The only way to change the direction of angular velocity, the angular momentum, is to reverse the direction of omega. Which means if this rod were to be taken from B to A, so if the rod was in my hand in the downward direction, the axis is here, and I bring it here. Now what happens? My omega has reversed, right? In this case, my omega is coming like this. So anybody who's standing here, for example, and sees that this is going like this, will see an anti-clockwise direction. So throughout the motion, the body will exhibit anti-clockwise motion as seen from here, and therefore the direction of the angular momentum will remain perpendicular to the plane of motion of the body. So you're moving in a particular plane, like this is a circular motion, right? This is a point mass maybe, and this is uniform circular motion, and the circular motion is in one direction, the angular momentum is perpendicular to it. So if I move my rod like this, right, and I say I will wrap my fingers along the fall of it is pointing towards the observer, which is me, right? So my angular momentum, irrespective of what angular velocity I have, because my direction is staying to be anti-clockwise throughout, will remain the same. So the correct answer is the angular momentum direction will not change in this question, but the magnitude of angular momentum will change. So you can select the appropriate answer. You can read the answer carefully. You can go back and increase the size of the question. I will just do it for you. You can see the choices. Okay, so let's see the choices, right? All right, answer 3. The magnitude does not change. The direction does not change, but the magnitude changes. I hope you like the explanation. Please don't forget to subscribe to this channel. You're going to see some outstanding exam-centric questions. You don't need to go anywhere. Stick to this channel. Thousands of questions, thousands of conceptual videos are already available. Join my community. Keep track of all the questions and the videos, because you are going to come across some special videos where I'm going to cover some more complicated and intricate concepts in a very simple manner. I will explain it, and they will help you score a very high rank in your examination. Thank you very much, and wait for my next video.